Welcome, folks, to our May monthly meeting. I'm Alexander Gard-Murray, Executive Director of Passive House, Massachusetts, and pull this off here so I can actually hold it. We're so happy to have you here for what we're sure is going to be a really exciting, interesting event. Before we dive in, though, I've just got a few quick items I want to go through. First is that we are tracking attendance, so if you are here in person, please make sure to check your name off at the front. We also have a QR code there for people seeking CEUs, or you go to phmass.org/CEU. But we'll verify your attendance using that sheet, or if you're online, we'll take a screenshot at the end to make sure you were here. So please have your name in your picture. With that out of the way, I want to thank the sponsors of Mass Save for making this event possible. Mass Save is, as you know, a coalition of the state's utilities. Coalition of state utilities supporting energy efficiency in the state. And there are really robust incentives for passive house construction. If you're building a single family, they start at $25,000, and you get started by emailing resnewconstructionma@icf.com. If you're building a multifamily project, like the one we're going to hear about today, incentives start at $3,750, with $750 of that coming from pre-certification. And you can access those incentives by emailing multifhr@icf.com. And I encourage you to reach out to them early in the process. That will make your lives smoother and easier. If you have any questions or want to access training incentives, you can contact Passive House Training MA@icf.com. And in general, if you have any questions about Passive House, you can contact us at PHMass. You can go to phmass.org and access our resources, and we'll do our best to help you. I'd also like to thank the members of Passive House Massachusetts, whose contributions support all that we do. And I also want to just quickly announce a few upcoming events that might be of interest to people here. So next week, Friday the 23rd, PHMass and EU Passive are hosting a Passive House social from 3 to 6 p.m. at Dungaharons in Newton. The more details on our website. And next month's meeting, we're going to have John Lorcher from Northeast Projects talking about some of the most persistent problems, deciding where to put things inside or outside the enclosure. Some other events this Thursday, the Studio for High Performance Design and Construction is having a barn raising projects tour. All next week, EMU Passive is having a design build boot camp that you can go and check out. FIAS is having their certified builder training at the end of the month, May 28th through 30th. And BE Plus, the deadline for proposals for their building tech forum is May 30th. And with all of that out of the way, I want to welcome these wonderful presenters who come to talk to us for tonight's presentation. We've got Nick Nigro from Leggat McCall, Andrew Steingiser from RDH, Ray Kettner from Stantec, and Gregg Walsh from Suffolk. I'm not going to spoil the presentation by describing the project in detail, but for my money, this is one of the most exciting passive house projects out there, and I'm just thrilled that we're going to get to hear about it tonight. So let's give them a big round of applause.
Good evening, everyone. My name is Nick Nigro with Leggat McCall Properties. I'm here tonight to talk about the wonderful Bunker Hill Housing Redevelopment project, which is a large multifamily redevelopment of the public housing over in Charlestown. As we were introduced, I'm lucky to be here tonight with our friends from Suffolk, Stantec. Obviously, we are partnered with the Boston Housing Authority for this project, as well as RDH, and then representing our talk tonight for FIAS, which was one of our main focuses with this project. I was actually started off with this nice little video that we put together, which kind of describes the tone and our vision for this project. Then we get into the real details of how we actually got there. I am happy to announce the building that we are going to be discussing tonight is 100% complete and fully leased at this point, which is awesome. It is honestly the first time I can say enough to present on it, say that it is done, because every other presentation has been merely speculative that we were going to get there.
One signature away from being certified.
Yeah, one signature away. Gregg.
In 1929, the tallest building in the world, the Empire State Building, was built in just under 14 months, nearly 100 years ago. Today, a 250-unit apartment building takes us twice as long as that to build. We've set out to try to change that paradigm by setting the audacious goals of building these buildings in half the time of current best practices for 20% less money.
The Bunker Hill Housing Development is the largest public housing project in New England. If you look at it on a map, it looks like it's about the size of a quarter of the 1 square mile of Charlestown.
We will ultimately be producing 15 new buildings of mixed market and affordability, totaling 2,700 units.
To replace deeply affordable units on site today with a new, vibrant, mixed-income community with open space, new interconnected street networks, new pedestrian infrastructure and bicycle infrastructure, and the highest levels of sustainability buildings today can achieve.
I'm excited about this project because we're deploying a new means and methods based around component construction, which is going to allow us to put these buildings together kind of like an IKEA bookshelf, where you have a series of different parts and pieces that you develop and then try to use that parts and pieces consistently across those 15 buildings.
We're using a kit of parts that include exterior walls prefabricated off-site. They have windows in place, insulation in place, the cladding, the brick, all of that's in place when it comes to the site. And then we have large timber panels that are 8 feet wide, 64 feet long in some cases, and a little over 8 inches thick. These panels form the floor system.
Our floor panels are cross-laminated timber, which serve as the structure of the floor, but also serve as the ceiling of the finished unit underneath. We're leaving these pieces of wood exposed, so we don't have to install drywall underneath that CLT.
We're also using precast cores for the vertical access for the stairs and the elevators. They're able to be erected on site very quickly with the stairs dropped into them. They provide structural strength for horizontal loads.
The concept of component construction is maximizing your on-site efficiency and driving productivity with the labor trades folks and giving them the best possible set of instructions to put together larger components rather than a series of smaller stick-built components. And instead of assembling 1,000 2x4s, right? We're going to combine all those 2x4s into a big wall panel, and that becomes a single component that is much more productive to place on site. All of that is what is allowing us to put this building together extremely quickly. This building was erected fully by 6 carpenters only.
You know, when you take people through this project who are knowledgeable about the construction industry and you tell them what you're doing and why, it's like, I get it. In describing what makes our construction technique unique, it's what isn't here as opposed to what we are doing. We don't have a structural steel framework for the building.
We do not have any columns or beams in this building because we combined that structure with our exterior load-bearing wall. We do not have any beams because the CLT is the structural floor system as well as being the ceiling, all in one component.
We don't use exterior scaffolding. We will not have an exterior material lift. We're focusing on thinking about these buildings as being a manufactured product with continuous process improvement.
The ability to learn from each one of these buildings is going to be paramount with our progress to drive efficiency and speed with this overall development.
This is a new way of producing housing. It's not revolutionary, it's evolutionary.
It's acknowledged nationwide that the residential housing crisis is among our most intractable problems. If we are able to, in fact, deliver a product in half the time for 20% less money, we believe that this will be an evolutionary development that dramatically expands our markets and makes a substantial dent in an otherwise intractable problem.
Good transition. We are extremely proud of this project. It was an absolute undertaking to figure out all the different dynamics, including the passive house aspect of this building, in conjunction with the component construction that was described, which we'll get into a little bit further. My goal here is to run through this series of slides, and then we will get into questions and answers with our experts as quickly as possible. But I'm going to give you a good brief overview of kind of the major points, and then we can get into some discussion. So as we mentioned in the video, this is a 15 building development over time in about 10 phases. We are going to complete it, we've been saying for, in about 8 to 10 years, but we've been saying that for about 5 years. That's just basically the road that it takes to get to the actual entitlements and funding and everything you need to get this thing on the ground. So what you're looking at here is a overview of these 15 buildings. Building M is the first building that we just completed, which is 102 units. This is a full LIHTC, full affordable building. You'll notice that there's 2 other light blue buildings in that picture. Those are also all affordable buildings. The rest of them are going to be mixed income with 22% affordable and 78% market rate. With the idea here that we are going to redevelop completely into 2,699 units while replacing the existing 1,010 units that are on site now. The concept here in our zoning envelope was really to work within a kind of 4 to 10 story range. These heights step down as you get down to the major thoroughfares, which is on Bunker Hill and on Bedford. Then you get more height as you come up into the middle of the site. Overall, when you think about kind of the density that we need to propagate this sort of housing, you need some height out of it, right? And otherwise, you're taking up all of the land area, which was basically the case right now with how the smaller buildings are spread out that are existing. As you get a little bit of a height, you can see here that we gain a lot of green space, right? So there's going to be a lot of public parks. It basically equates to 70 acres of open area that will be available to the public, which is awesome. We end up also with some nice retail, and then there will be a 14,000 square foot community center that will be provided to the folks. I think we're looking for phase 4 to get that done. So right now we have completed building M, as I said, and then building F is the second building, which we are currently working on getting in the ground. We're hoping to do that by the end of the year. We are working with Stantec and all of our consultants right now to work through all of that to get it together. We are very excited to roll everything that we learned from building M, which was immense, into building F. And you'll start to see as I talk here, really the concept is it's very rare in our world to be able to have 15 times to iterate on something in a row. We tend to build one-off, custom cars kind of in this realm. This is an opportunity with some serious volume to put yourself out there a little bit. Building M was a 6-story building. You could have built it out of stick, but it was really taking a learning curve, convincing everybody that this is about the long game, and then trying to really deal with that interesting height that is the third bullet point here, which is really kind of no man's land is what we call it. 7 stories to 12 plus before you get to 18, 19, 20, where you're getting back into traditional steel or concrete. There's no real building system that kind of fills that gap at a real economic price. So our goal was to really reap the benefits in that kind of odd height realm with our hybrid construction system. We really started from the inside out on these buildings when it comes to design. We really have a rent optimized to cost based off of the square footage of the usable space. We're really limited bathroom and kitchen types. You're not having 40 different configurations of your bathroom. You have, 6, sure, somewhere around there. A few different kitchen types, trying to really standardize your different parts and pieces, and then be able to iterate them on as you go. Building forms were optimized, for energy performance, and this is one of the major points that I would like to point out. Obviously, with our discussion today around passive house. One of the earliest things we did was put an energy model together. So mass the building out, optimize the glazing ratio, optimize how you're looking at your facade and the form of the building. We also wrote some really serious rules around what you can and can't do with your components. We're not going to have any crazy overhangs. We're not going to have any rough openings that are larger than 6, 7 feet. It was establishing a real serious set of guardrails as we move forward with design of each of these buildings. But It has been an awesome learning experience. We're very happy to, roll that into the next one. If we kind of just break down, what the actual components were here, right? We're looking at, prefabricated exterior walls that are light gauge metal frame right now. As we mentioned, they came out fully realized. So this was, I would say, one of the hardest components that we were, challenged with. Given the fact that you can find many fabricators that will build you a non-load bearing, fully finished, glazed, insulated wall, but to do that in a load bearing sense was very difficult to find anybody to do. There was, shop drawing issues, there was testing issues. We'll get into all those thoughts, but it was something that we believe is truly paying off as a result of, again, the concept of combining and maximizing value into each one of your building components, and then not spreading that across 1,000 different pieces, but condensing those pieces into more valuable components. Second is our cross-laminated timber, which this was my first foray into dealing with CLT. It was awesome. I think everybody can agree on the design team, construction team. Nobody's seen this before. We mentioned that it was built by 6 carpenters, which is kind of wild, a crew of guys that had no experience with CLT before, picked this up. By the time they were up to, the 5th, 6th floor of this building, they were rocking and rolling. It was awesome to see. The third component here is precast cores. This was another important decision that we made in, where we sometimes fall down in our industry is we still, tend to compare things apples to apples, right? So you look at a typical CMU core where, that might take 3-4 weeks to build. It might be pretty standard and lower cost, but you're not getting as much composite action out of it, right? What we went with is, these precast cores, because I can erect each one of them. That building that we just built, there's 3 cores. Weak a core, drop the stairs into them, and then you have vertical access immediately up to the building, and then we build the building around it. What that provided us with that access, and then also taking all of the lateral load of the building, we have no shear walls in the building, right? So it's the stuff that you're not doing is where you're gaining your efficiencies. And we tend to not holistically analyze early enough and try to figure out how you put these things together and then the trade-offs that come with these items. To really make these decisions. And I'm saying this because this is where, a lot of developers and others in the community get scared away. You look at the cost of CLT, you look at the cost of, a traditional structural deck, and you're like, no way, you run for the hills. When it comes down to it, it's the speed that you get out of it. It's the sustainability. It's the not putting drywall on either side of it that's cost, that's saved. There's a lot of ancillary benefits that you really need to drill down into to convince yourself that yes, holistically, this makes a lot more sense. And the fourth item there is, potential for prefab bathrooms and kitchens. This was kind of our fourth, we call them, our kind of core items here that we were putting into these buildings. We were unable to put that together as a result of some labor issues, but we hope to be able to do that in the future. Because really, if you want to drive speed of construction, all of your mechanical condensed, in every single unit into these, if you put them together, prefab them, drop them in as you erect the building, and then make all your final connections. It's about driving efficiency in the field to get heads and beds as fast as you can. So with that, picture here of building M, which I mentioned we just completed. This is a 6-story with no podium. This is building F that has 265 units. This is going to be our second building at 9 stories. So really starting to push the boundaries here of kind of the height realm that you can get out of load bearing, like gauge metal frame construction. But this one also sits on a steel podium that has 50 or 60 parking spots in the bottom floor of this building. So how did we get there? It was a journey. And as I mentioned, really the first and very early thing that we did, if you look at this chart on the left here, this is us doing some energy modeling, looking at a swath of different combinations of items. So this is taking different windows with different U values, looking at different thicknesses of our mineral wool, kind of modulating up and down with each of those to try to dial in what we thought was the most cost-effective combination. Where we ended up was kind of amazing to me. We have only 3 inches of rock wall on the exterior of this building. So continuous insulation that is like a blanket around the building. That's why I put this nice section here. That dotted red line is basically the outline of our passive house envelope of this building. So there was extreme care taken to making sure that that was as tight as possible. and being able to design yourself into a situation where you can actually accomplish the details in the field, which we found out, you'll hear from Gregg, some of them were pretty difficult. Yeah. The axon that I have there is really just to kind of show I don't want to say, simplicity of it, but really it is. It's a load-bearing, platform-framed building. The actual structure of this building is a very simple building. The architecture is pretty straightforward. The challenge comes down to the combination of all the different components, the tolerance of all those different components, and then how do you put them together as fast as you possibly can. Right? The challenge of the design is in the details and the sequence of events that need to happen logistically to actually bring it to fruition, right? And then my final item here on the bottom right is the detail that I'm pretty sure Ray drew, which is, an amazing amount of iteration and effort to get to something that you can get all of your consultants on board with, to get everybody to buy into that this is a system that's going to work, and especially in this load-bearing fashion. That is very atypical. This is something that we're kind of, really inventing to make this system, specifically work itself, which was an awesome challenge on the design side. After you do all the design, you then got to put it in a facility and then spray water at it at 100 miles an hour. It's fast. They depressurize inside of it, so it's also sucking the water through. And then we're trying to figure out how our interaction of our panel joints come together. One of the major challenges with this, system was that we needed to maintain a 3/4 inch gap. Basically, was our design tolerance between each of the panels, and then we go in and then we bring a primary seal and a duty seal that brings it all together. As I mentioned, the interaction of precast, light gauge metal framing, and CLT was a serious challenge to be able to make all those tolerances work. If we want to get better in this industry, the number one thing we need to do is get out of the realm of if we, put a core 10 stories up in the sky and stand back and we're like, no, that's within an inch of where we're supposed to be. We did a great job. It needs to be within a 16th if we want to advance ourselves. That's how every other industry looks at it, and we just do not do a good job of controlling our tolerances, designing for those, and then sequencing how they're going to interact with each other. It comes down to, I truly believe that we still have not gotten into an actual digital twin realm where we're understanding our screw heads and how are the screw heads, the buildup of the AVB. And, the interesting one to me that I'll mention is that if you think about a CLT panel that's routed out on a table, right, by a CAD machine, when that little arm goes in there and it's cut, it can't make a 90-degree cut. There's actually a radius in that inside corner, right? That radius is, 1/2 inch. Our tolerance was 3/4. So we just ate up half of that, right? These little items that you only learn when you're out there physically touching and feeling these parts and pieces. The beautiful part is, though, guys, is that we learned all that and now we're packing it into the next one, which again is the unique aspect of this, right? Where you get to learn, really refine and then drive that into your next design set. So this was a really harrowing point in time where we're trying to drive all these details, something that really nobody's put together before. We went through, I would say, several rounds of testing before we got to a place where everybody we were passing with all of our different configurations, and it was a great moment. Where we went from there was actually building the components and putting them together in the field. As I mentioned, the construction time is one of our major focuses here. You can see from our president Eric at the beginning of the video there. He is really stuck on the Empire State Building and how 100 years ago we could do this in half the time that we are currently doing things. We need to get back to a realm of almost a master builder where everybody's working together to really figure out how to drive these construction durations down. The CLT, as I mentioned, was one of the most productive installs of material I've ever worked with. By the time the crew got good with it, they were laying down 7,000 square feet a day, which was incredible. We did, 21,000 square feet of exterior walls. We basically had a 2-week erection cycle per floor in this building. We started erecting it in February, and we topped out in June, and then we were weather tight like 2 weeks later. That's a result of having all the exterior walls done, basically making yourself a box as you work your way up. And then having also the advantage of CLT is, exposure to weather, and there are many different opinions. Me and Andrew went back and forth sparring on what to do many times. And, at the end of the day, being able to cover up your floor as you go with your walls, where you're not left exposed vertically for extended period of time is also an advantage for that building system that we thought was, worked out really well. So at the end of the day, really what it's about is optimizing your on-site productivity, minimizing your waste. I hope to get to a point where there is literally no saws in the job, right? Where you're going out there and you're putting together a erector set because it was thought about so well, toners are so precise that you're really just connecting bolts together is where we'll get to someday. Then obviously accelerating the speed to market is, one of the most important things, especially with a long-term, very large project like this. So where does that bring us? I mean, that gives us, what we end up with here at the end of the day is, really a minimized, carbon footprint, our operational end as a result of our, passive house envelope, really provides the downstream benefits when it comes to the operation of the building. Obviously, it sets you up for, the potential for, some net zero application through some solar or other renewables. We do still have one, gas system in this building, which is our domestic hot water. We have not yet got to a point where we found a system that is both first cost and operationally effective. Maybe that'll come in time, but right now, that is still by far, what we found to be pretty driving. The code has changed since we built this building, and we will now be building the second building with PV day one. In order to maintain the fact that we were still going to have a gas-fired system in the second building. So again, we get ready on time. Technology comes along, and at some point, all these buildings are ready to be retrofitted with electric as everything advances. At the end of the day, what are we looking at is providing awesome housing, for both the affordable residents and then the market rate as well. But I can't stress enough, honestly, the exposure of the CLT in the unit compared to walking to a typical white box, that you go into any other unit. It adds a lot of warmth, really, nice dynamic coffer that sets you up into the, much different feeling, I would say, of the unit. So aside from all of the awesome construction benefits, sustainability benefits, I truly believe that there's a health aspect to living with some awesome natural material in your unit. So after we built it, what do you gotta do? You gotta then see if it all worked, which was, another point in time that you had no idea. I mean, we did maybe 2 or 3 interim tests before we got down to our final air test, with the actual certification round. I was astonished that when we did our first test, we actually passed it. It was wild. And to give everybody context, I was trying to, as we were going through this process, I really didn't understand, when you think about how much air is, escaping or being allowed to transfer in and out of this facade, like how much is that? Like what is that, right? It was explained to me that if you were to cut a 40-inch by 40-inch square into the side of this facade, that is basically the amount of air that is allowed to transfer in and out in order to get certified under the threshold. So that, gives you a little bit better idea. If you add up all the cracks, all the little holes, right? Like that 40 by 40 square is how much that needs to be under. At the end of the day, we were able to, pass the test. I think it was a solid margin. It was like a 20% margin, which was awesome, right?
35 inches.
Yeah. And we worked our way through, some of the compartmentalization tests, which is inside of the units. All was, again, even a little learning experience for Suffolk as they try to figure out, they bought their own blower door, went around, tested, some individual units on their own, trying to figure out where the pain points were, and then replicated that as we went. And then you see here some of the, thermal imaging that's done to try to find out where the problem spots are. And that was it. Please, again, we are extremely excited about the project. We'll answer any questions that anybody has.
Yeah, you said you keep that one.
We're going to alternate to questions in here and questions online if we have them. Who wants to start us off? And if you just introduce yourself and it's hot dog, not ice cream.
Hi, my name is Christian. I was wondering whether the stair cores are considered as conditioned space within the passive house envelope. One of the problems often is the difficulty between passive house ceiling levels required and fire safety. And those doors are defined that satisfy both.
Yeah, I mean, the answer to the first question, yes, the stair core is part of the passive house boundary. The issue is the exterior door is the hard one to really get to seal well. And our other issue was where doors are and then egress for resiliency. We had a couple doors that are like below the floodplain, and all of a sudden that is a much different door than the door above that's, you know, where it wants to be. But I don't remember any, we were able to get them, there was not anything additional we had to do on those doors in particular. But the stair is part of the regular stair, part of the passive house.
We don't have an online question yet, so anyone?
Thank you. I had the privilege of visiting that site and helping out with that first floor door test, and I was blown away by the crew you had on site. Just really, really impressed by the young people that you pulled in for every role, it seemed, in the job trailer. And I wonder if you speak to that a little bit, like how this team came together and how you threw it together.
Some, not by choice, they just, thrown into it. But some of them definitely had an interest in learning it. It's, we see where the industry is going, as you know, Nick has touched on before, and this is an evolution of building. So there was definitely people that were wanted to be part of this. And like you said, because it was so new, I think it's one of those things that everyone wanted to be involved on those door-to-door tests that we were, so although we had to lock everybody in that building and, you know, we might have promised them pizza when the test was over, they were interested in being there because they really wanted to see how, you know, and they worked hard on it too. And so they really wanted to see their hard work pay off and to see that, and when results came in as it did, where we were 20% under what we thought we were going to do, I think it really bumped up the team. But at the same time, when we left that, we also had to take another step back and say, while this is great, enjoy the moment, but at the same time, there's still a lot of hard work that's going to be happening over the next 6 months, let's say, as we continue to finish this up. Because when we did that interim test, we were able to tape a lot of the joints that we had concerns about. The roof hadn't installed like the curbs and the ERV units on them yet, so that was a concern. There was also the trash chute, that was another, and it was good because we also had a team that had gone through some passive house projects before, and so they were able to point those things out to us as well as like, hey, as you get closer with that trash chute, make sure that you are making sure that all those joints are tight, because that is one of the things that has in previous projects given issues to other teams when they're going for the retests or the final tests. So it was definitely, while we enjoyed that moment, we knew that our jobs were not done. And so that's what the kids and the team continued to work on that.
We may have instilled the fear of God into Suffolk on whether having to pass the blower door test. And when they finally did, they would, every OAC meeting ended with, oh, did we mention that we might have passed the blower door test a week or two ago? They were very proud of it, and there was an achievement well worked.
Yeah, other than the walls, I would say, you know, one other challenge for the team when we came together was coming out of the slab, right? So before we even got to our air testing, the first layer that you have to deal with is your slab on grade, your insulation layer, your ABB, and then dealing with a whole bunch of atypical conditions that, you know, the contractors have really never dealt with before. Which took a lot of team effort to, you know, really understand what they were doing, what they were trying to achieve, prior to erecting building at all.
All right, we're gonna go online.
Pete Russ is asking, how did you decide to construct the exterior walls using metal framing rather than wood framing?
Great question. We went through, I would say, a solid year before we even had an architect on board. We had Suffolk Construction and we had Max Sal, who is our structural engineer. We sat in a room and we ticked through, I don't know, a dozen different combinations of structure. It started with light gauge, it started with obviously stick is just there. We do this as a 6-story building was the first one, but we didn't want to commit to, you know, a building system that wasn't going to be consistent. The whole goal here was to have a building system that you can go from 4 stories to 10 stories, not change anything. And iterate on the components to do so, right? So you want to stay within that lane and then drive it. We ticked through 1,000 different things. You know, we ended up on the combination of the light gauge exterior framing, because there are contractors and subcontractors that are still, you know, used to prefabricating that type of stuff. The ask, you know, beyond just typical prefabricated light gauge wall was obviously doing it in a low bearing fashion, as I mentioned, and then putting the ABB, putting the girts, putting the insulation, putting the windows in, and then shipping that entire thing without damaging it, and then flying it, and then tipping it, and then dropping it in the building with all of it, you know, maintaining its integrity. You know, I think in the world of CLT, you know, we are slowly progressing and trying to get out of, I would say, you know, traditional stick construction to more of a mass timber construction realm. I am absolutely, this will be the, let's put it like this will be the last one that I do with light gauge walls. The third one will be CLT walls. And a lot of that comes down to, you know, we'll start with sustainability, right? The carbon footprint that you're getting out of that building is going to be that much better. But it also goes back to what I mentioned about tolerances. You know, you get that 62-foot panel, 8 feet wide, right? It's 8 3/4, 8 3/8 inch thick. So that's a 7-ply panel. It comes out within 1/8 of dimensional stability, right? It's just incredibly tall. It's so tight. Try to marry that with a light gauge wall that's, you know, 30 feet long, that's put together by human hands. You might get that within 1/2 an inch, right? So we're almost magnitudes out of whack with what we're trying to build with on the CLT side. You know, imagine now taking your entire building and just routing it all out of a CAD file, right? That's where we're going. I will also, you know, give it another positive in the fact that, you know, back to what I said before, is like less is more. You think about all the things that you are not doing with a CLT wall panel, which is, it's a natural thermal break. It's also a naturally an R6 if you're using a 5-ply panel, right? So you're not dealing with all of the traditional things that we're trying to mitigate with different standoffs and rubber pads and, you know, whatever we're trying to do to break that, right? The wall is already inherently like that. You put some AVB, you put your GERT system. Actually, I'm not even going to go with the GERT system. We're going to go to, I'm really interested in this night wall CI system now, right? This night wall CI system, when I say that, it's a continuous insulation system, right? Where you are blind screwing through your 3 inches of rock wool. Blind screwing through that 3 inches of rock wool into a metal stud backup wall where you have to hit every single stud perfectly is not possible, right? You walk me off that ledge. With a CLT wall, it's a solid panel behind it. You've no problem, right? You're just zipping that thing through. You know, the simplicity of it becomes amazing. And then you clad that, you know what I mean, with really whatever you want. But the sandwich that you get with the CLT wall is actually, based off of my current calculations, much more efficient than it is with the light gauge assembly, which would make you, like, you'd never think that initially. It comes down to that holistic analyzation, kind of really looking deeply at it, all the stuff that you're not getting out of it, you know, to make the decision. So we're going back to wood is the point. It's just not going to be, you know, traditional 2x4 or 2x6. It's going to be into a real mass timber realm for vertical and horizontal.
Hi, I'm hoping you talk a little bit about mechanical systems, your heating, cooling. I know you mentioned you have gas, hot water. But it's even more important, you can talk ventilation and how that went and testing and how you're actually ventilating those, what type of system you're using.
Take that one. Should we bring up James to talk?
Yes. I was just gonna say, someone in the audience, right?
And John tested it. So we have 2 ERVs on the roof, and then we have VRF. There are the combined VRF, but it's old generation, not our current generation of refrigerants. Single heat pump basically in the unit, and then we're feeding that from branch box, combined branch box. And then those are ducted. So the unit itself is in the center of our units, and are ducting air to each of the bedrooms and to the living spaces. And then we're combining the ERV fresh air with a car damper so that it's not two sets of different, big louvers in each room. So it's a sort of, you can talk about whether you like those as an approach, but as an approach, it simplifies a number of.
Again, it was something that we hadn't used before, but when it started to go in, it was very efficient in terms of the installation with regards to the duct contractor, and what needed to be done. Duct is always gonna take up a lot in your corridors in terms of the coordination, which, you know, we were able to work through. The ERVs were, you know, I sort of touched on it a little bit with the, curbing that's associated with it, as well as the units, and making sure, because they are set on like, springs. So it was a little bit of a new installation for me that I hadn't been through before. In terms of the testing, we did go through some struggles with that, because I think it is a newer technology where, one of the challenges that we had is that the balancing contractor had thought that he could. We talked about it with them where they said you need to use a vane anemometer with a cone so that you can specifically measure where the car damper is versus, measuring both of the, grills, I guess you could say, that are the combined grills. And he thought he could just do it with the vane anemometer, so we didn't think we were getting the actual values. And so that was a little bit of a struggle that we are working with them and having them go back through the whole building to retest it. But all of the results came back good. So in the end, it worked out, but it was definitely a learning curve, not only from like our side in terms of the installation of it, but also even to the point of the balancing contractor, the CAD contractor with regards to finalizing the system.
Yeah, and I would just add to that kind of two items we passed over quickly there. In the passive house realm, it's a really nice aspect to be able to put your fan coil in the middle of your unit, not on the exterior wall. All right, so traditionally, you're trying to kind of mitigate the loss that you're getting from exterior wall with your windows and everything else in the old, less efficient realm. So you put that on the exterior wall and it kind of moves across those, across those space and then feeds back in. In a passive house realm, the triple glazed windows, you know what I mean, an extremely tight envelope. You can dump that air, into the unit in the middle and not be affected if you're standing next to the exterior wall and window, which was really nice. On the ventilation side, this is another challenge that I'm trying to work through. Because right now, as Greg alluded to, we have a lot of ductwork that's going down the corridor. So right now we distribute vertically from our ERUs, and then they ERV, and then they go down the corridor and then branch off in each one of the units. I'm working with a 10'6" floor right now. I'd like to, optimize that or localize that in some manner to try to get to a 10-foot floor straight up. And again, if you think about, your facade to floor ratio, right, every inch you get back out of your height is less, surface area that you're building from exterior wall.
Well, we have another follow-up question about mechanicals, so it's perfect here. Kelly Moore is asking if ground source heat pumps or wastewater heat recovery were considered.
We're considering wastewater heat recovery now, James.
Yeah.
Ground source heat pumps, we briefly, looked at that, returns and, our efficiency and all of that. I just haven't wrapped our arms around, finding the value in that yet. I will say though, moving to a more localized domestic hot water system where you're preheating or raising the water, ambient temperature up to something that is really okay for maybe more traditional resistance water tank heating is something that we're considering now, and that would be combined with perhaps some solar, right? Some solar heating of your water, and then your waste recovery with a coil around those stacks is something we are looking at. I wholeheartedly follow the philosophy of simpler is better, right? That the more simply you get out of it. James, was a big proponent of honestly, getting as many compressors out of the building as possible, right? Now we're starting to pack compressors into the building. That's your most highest failure point, right? It's simplify, is everything I'm trying to do to really make it as streamlined and simple and replicable as possible.
So we said we're just iterating, we're just gonna do the same one, but of course, refrigerant change in our next building, so we have to rethink what's our next system. We're looking at 1-to-1 potentially there. And then this one, the air seal is on the outside. We're looking at trying to do the air seal on the inside. So the iteration is it's the same building. the same building at all each time. It's kind of fascinating to be able to do it. I mean, we've learned a lot of lessons, but it's gonna give me a lot to learn on the next one too.
So, no, I love the excitement about driving down the time it takes to build a building, even on the design side, that chews up a lot of money. So I love that, and also just all really focusing on simplification, so more on building systems, whether it's plumbing, waste and vent, or electrical infrastructure. I'd be really interested in some of your, what's on your wish list for simplifying those.
Well, I can speak for me, but I
Go
know
ahead.
that, and Nick touched on it, but it was the prefab of the kitchens and baths. Although we had several meetings with the trade contractors to try and figure out an equitable solution to it, they just couldn't achieve it. But I think that one will be a huge savings. But with each one of these savings, I think it does create a little bit of a challenge, because one of the challenges that we would have is that a lot of the components that we installed in this building, it was so new to the building department that it threw them off. So I think that was another one of the concerns, is that we have to make sure that while we're trying to advance and you know, create this evolution of different systems, we're also bringing those teams into it, ISD, BFD, just because it is so new to them to understand it. But I think that is one that can definitely, you know, bring about definitely saving some time for sure.
Can you just tell us why, what was the problem with?
It was all a function of just they wanted their crews to be able to build it on site versus having it built in a factory.
So it wasn't like.
And so that's why we were trying to find equitable solutions where we were looking at even factories within Massachusetts, so that we could say, hey, it'll be prefabbed by union workers in these factories, and it just didn't come to it.
We'll get them there.
Automation will supersede all of that.
Just a couple other comments on that here. So I can see a world, so we're, you know, ventilation wise, HVAC wise, I think there's many options that we have to keep driving simplification. You know, I wonder if we're gonna get to a realm where, you know, you're getting to complete packaged, kind of exterior, back to the exterior wall, we'll go back to the exterior wall, having a complete packaged, you know, ventilation system and heat pump all combined into kind of one unit. Those are starting to, you know, seen in Europe, some in Canada as well. So that's, you know, a potential there, but in terms of reliability and engineering, you know, I'm not sure that we're there yet. I think, you know, on the other end of it, this is a little bit, you know, adjacent to what you're asking, but I think the next horizon that we really need to pass is getting rid of our diesel generators. I think the cost and the effort and the infrastructure that goes into putting that generator, luckily with the first building, I was able to find space in the ground, so it, you know, it mitigated the impacts, but the second building, I have no space on the ground, right? So this generator is sitting on the roof. We are trying to redesign it to find a place on the ground. I know, Gregg, we're not there yet. But you think about just the cost, the infrastructure, all of that, right? You know what I mean? To have this, you know, fossil fuel burning generator. As I understand it, there's actually been a project of smaller scale in the city. It's about 50 or so units that got a battery backup system to basically get through BFD, where they, you know, I think they basically just maintain that there'll never be a drawdown less than 20% of the capacity of the battery, and that 20% will always then provide any emergency power that's required. I'd love to see us get to a realm where we can, you know, make that the precedent and really not the exception.
Let's see, at what so Cam Berkacci, sorry, Cam, at what intervals did you perform early blower door tests? Were these tests performed on individual sections of the whole building? Great presentation.
I'll say. Well, it's been great hearing from everyone else. So great idea to do the first blower door test as soon as the building's airtight. So, and it was, so once all the panels were in place, the windows were already in, at that point, not every door was in, right? So we temporarily seal off.
I think the storefront was also like the entry was that right?
The entry was not-
So let's call it like 80, let's call it 90%.
Yeah.
Right?
Yeah, because you know, the entry with storefront was still the access point for bringing materials in and that much, right? So at that point, we're almost there, so able to mask that off and passed the first time. We ended up doing a second one further along. What point were we at there?
We were getting close. We were at probably the 90% point, and one of the other challenges that we had was just that the location of the building is just, it was a difficult spot, as John mentioned, and it ended up the day that we tried to do this testing, it was just like every location that we tried to set up the exterior lower door system, we were just getting a significant amount of wind that was just throwing off our testing. So if you're trying to get that cycle of getting a reading, you would just get significant gusts of winds that would just throw everything off and you'd have to start over fresh. So while it gave us some good information as to any potential weak points that we had, we didn't get the full results that we were looking for, but we went into the final test pretty confident that everything was gonna go well.
To add to that, I should back up. We had performance mock-up testing, which is critical. With a system that we're kind of taking the first pass at, really critical to do that testing. Nick had some photos. What wasn't totally apparent was there's a back chamber on that, so we could perform a whole building test on the extent of the performance mock-up. So that provided us with insight as far as the airtightness, and let's not forget the other control layers. We think a lot about thermal and air and passive house. Let's not forget water. And you can pass a whole building blower door test when it's averaged out over the entirety of the square footage of your building closure. But that same little pinhole that may be inconsequential to the whole building airtightness test may be a source for a stream of water. So those two things together are really critical. The joints are super critical. And so we learned a lot. I think this was the second PMU we actually had. We had one before that. So through those 2 rounds of whole building testing, in addition to water testing on the 2 PMUs, that informed our detailing and sequencing and construction before we actually even got to the building. So that helped not only finalize the details, the shop drawings, but it helps towards the success of that first whole building test too.
So I presented on this actually 2 Decembers ago at the PHMass conference, and that's the point where we had no building, we had 3 cores. That day was when we had that, and that we finally passed the test.
Yeah.
So what's crazy is, so that's 2 Decembers ago, now it's fully lived in and fully leased and in operation. The speed between there and where we got is crazy. Awesome.
Just a couple of the other things that we had done as a collective team was when we started to see the building go up and what Andrew was just mentioning, we thought that, it's the old saying, what is it? The nickel prevention was worth a pound of cure kind of thing, where what we did as well was we looked at our exterior facade and we knew that we weren't going to be able to do it on a higher levels, but we found probably about 3 or 4 locations around the exterior perimeter of interesting or odd locations where we wanted to perform dynamic testing. So we brought Intertech out. That same unit that you see in the thing there, they were able to load that onto the back of a truck, bring it out to us and perform that same test in situ right there on site. So we found about
I was gonna say, for anyone who's not familiar with that, that is a prop plane engine, right? That is spinning, that is creating 80-mile-an-hour wind, that is blowing water and wind at your depressurized interior chamber. It's like no joke.
And so with having that out there, I think it started to give that team that confidence as well when we had these locations where the cast stone on the outside of the building, the panel heights changed, or where the curtain wall storefront met our panels, where the precast stair tower met into the traditional panels. Just details that we were confident on, but we definitely wanted to, make sure the belts and suspenders that we had achieved what we were looking for. So we did that about 4 or 5 locations. We failed a couple, and so we learned from those mistakes, and then we brought them back out there, retested, and were able to get everything signed off. One other thing that I would just say, and it was touched on earlier, we ended up going and getting ourselves a blower door. Believe me when I say we don't have the expertise that the crews that came out from RDH had, but we were able to use the information to our advantage, where if you're seeing a dramatic where the unit's not holding when the one right next to it was achieving that something was wrong. And sure enough, it's what we all say. We thought we checked every, fire caulking around every pipe or fire caulking vertically through something. And lo and behold, you'd always find 1 or 2 that were missing, and that was what brought us over the point of getting that passing. So we did a lot of the unit compartmentalization and testing as well for ourselves.
Lessons you take as presenting at the symposium is causally good for your projects.
I have a follow-up question, because as I'm thinking through this, right, you have these panels that are coming that already have the exterior cladding on them, so how do you make them airtight? Since you can't really tape that on the outside or anything like that, so how did you work through that connection to make them airtight and water safe?
Good question. In the end, it's kind of a dumb detail, but
That's the beauty of it, though.
but it is materials everyone's familiar with. When we started, this always felt like the crux on this project. How are we gonna get these things that are fully realized to show up, and then nobody needs to do anything, and it's gonna be great. Everyone wanted a chicken head detail, everyone wanted it, a classic curtain wall detailing, so everyone can forget about it and not have to actually engineer it. In the end, we have a panel, a rectangular panel that's built out of studs. We've got sheathing on it, we've got ADB on it. Around the perimeter is an armatherm angle that is embedded in the ABB, and then the ABB is then wrapping the sides of the panel. And that armatherm angle then is tied into our air barrier. And then when the panels show up on site, we've got a 3/4 inch gap between them. And that is got 2 layers of sealant on it. It's almost like precast detail by the time we're done. You're sealing, the primary air seal is back where the sheathing is. And then you got another one, beauty seal at the front that is covering the gap. At the sill, the issue is, if you just build a rectangular panel, we've got a section that's all CLT. And we worked on whether does the CLT sit in the panel, does the CLT sit behind the panel, multiple iterations of that. And in the end, it's like, what's gonna sit on top of the panel? So there's an ABB strip that gets lapped onto the top of the front edge of the panel, lapped onto the top of the panel below. And then when the next one comes by, it's actually cantilevering past the slab. So you've got cladding extending past the slab and past the CLT.
One line you can't see, right? This is that ADB, right? So it's coming over, it's lapping down on top of the other panel, and then you're sitting on top with this cantilever piece that's sitting over the side to make your joint here with your angles that are awesome.
So you get a nice L angle there, which is kind of nice. So all the water's coming down and then shedding out, and we've got flashing at that joint every 2 stories. And I think one of the reasons that you didn't have somebody installing windows in the field, so every single window was a bespoke version of how a guy wanted to think about installing window. You have a set of folks in the factory all placing the window flat, panels all flat, and they're ABBing in, and then they're putting insulation in flat. I mean, it was kind of weird to watch the side camera, and there's dudes standing on the panels, like they're just hardy panels, and they're just standing on them. But that's not finished product. Why are you standing on top of the hardy panel? It'll be fine, but the story, Nick tells a good story about it's fully realized. I think one of our challenges was brick, and it was really more of the timing, how we got it out there. So they did most of, if not all, the brick on site. So, but it's a thin brick system that you clip in. So again, that's pretty easy. And that felt like that was gonna be another one of the challenges, like how are we doing brick that's coming off site? So that getting to a thin brick system is really the way around it.
Yeah, this picture still pains me, even though it was, in the depths of, trying to figure this thing out. You can see that there's still poly on those, lower floors. That's my dirty secret, that we didn't get the finishes on the lower floors. Until we really started to figure it out. You see on the top floors, everybody started to fill it in. The fourth, fifth, and sixth floor, came out fully realized. Our second building, now that we know all the tricks, will certainly, come out fully realized. Before we got to the actual detail of how the panels come together, it was another journey of just getting the panels themselves to be tight, right? So we got to the point where you have your ABB, you have your angle, and then every, I don't know, fourth or fifth panel, I think, in the factory would flood. So it was laid horizontally as they're building it. You fill it up with an inch of water, and you let it sit overnight, right? You can see the water comes out of it. So by the time you're done with that, right, you have a really high confidence that the panels that you constructed in the factory are super, super tight. The integrity of these are awesome. Everything comes down to the joint detail, right? And then trying to stay under that 40 by 40 inch square, within those joint details of messes.
Yeah, and then joint, so the air and vapor barrier is outboard of the sheathing, right? It's rain screen wall. So we want to maintain that air, vapor, water seal as close to in plane with that as possible, which from the exterior, and thank goodness we didn't have more exterior insulation than that, because there's already a challenge to get caulk in there and get a consistent plane across all these panels. That inner seal that's doing all the work, right? You've got things to say about that, I'm sure. And then the outer seal, which is effectively the beauty seal, but so RDH has had other projects. Now, the unique challenge here is load bearing. So that's the unique challenge. This is more like a curtain wall flying by the edge that simplifies things immensely. So, that silicone joint's doing a lot of work on the next building. I don't know, can we talk about it?
Yeah.
Yeah, okay. Oh, okay. Alright, we're looking at moving in the interior and, well, more to come on that, we'll present.
Yeah, and the whole goal there, just to end with that, right, is, back to productivity. Don't do anything on the exterior of the building, right? That's the whole point. Right now, all we're doing is exterior seal, move that inside, and they don't need to put any guys on the outside. We'll get there.
We still have a bunch of questions online. We're not gonna be able to get to all of them because we're running the time now. We're gonna try, because some of them are sort of yes, no. You guys have proven your ability to work quickly and optimize. So we're gonna rapid fire that at you, all right? Lightning round. And you can say not sure or too long an answer, you can pass. Okay, we're gonna try and get through as many as we can very quickly.
Trash collection and disposal handled, what's in and out of the passive house enclosure?
Oh, so with trash collection, what we did leave one, we found the location on the perimeter of the building where we did, that was sort of our load in, load out window system. So it was only about 5 windows throughout the whole building, and all of the trades were able to bring any of the debris or refuse that they've got. And then we had a lull that picked it up throughout the day. And we would also load materials into that location. So that's how we achieve that.
Building trash chute is outside the passive house boundary, and the trash room is outside the passive.
Okay, more faster.
What air sealing details did you use at the exterior panel connection? I think we just connected that.
Yeah.
What was modeled with, did you model anything with a straw panel?
Straw?
Okay, I think that's the
Yeah, that
answer.
would be version 5.
What sort of topping is used for each CLT deck? How do you maintain a waterproof layer above the CLT?
The gypcrete system that goes on top of the CLT. So about an inch of the foam, or we did look for on one with.
Yeah, I mean, real quick on the assembly, so it's an 1.5 inch of gypcrete with, well, we'll start from the top. LVT with a little bit of a rubber backing to it. 1.5 inch of gypcrete, there's an inch rubber sound mat, and then there is your 8 3/4 inch seven live ply. Second, what was it? Next.
next. I think that's it. I think that's all we have time for tonight. Everyone join me. Give me a big round of applause for our speakers.